let us derive three equations of motion by graphical method. The equations of motion are also called as kinematic equations. The three equations of motion are v is equal to u plus at, s is equal to ut plus half at square, v square is equal to u square plus 2as. Here, u means initial velocity or the starting velocity, v means final velocity, and a is equal to acceleration. T is the time taken and s is the displacement. Now, let us consider a velocity time graph. That is, velocity is taken in the y-axis and time in x-axis. Here, we will consider a body starting with initial velocity u. Let it undergo uniform acceleration and let v be the final velocity. Let us plot this v and let t be the time taken to complete the process. That means if we plot the graph, we will get t. Now, let us name the points in the graph. They are O, A, B, C, D and E. From the figure, I can easily say OA is equal to initial velocity u and DE is equal to initial velocity u. Therefore, I can easily write OA is equal to DE is equal to u. Similarly, we can see that OB is equal to final velocity v, CE is equal to final velocity v. Therefore, I can write OB is equal to CE is equal to v. To find the equations of motion, we need the value of CD. Now, we know that CE is equal to v and DE is equal to u. So, if we remove DE from CE, we will get CD, that is v minus u. So, simply we can write CD is equal to v minus u. From the figure, we can find out that OE is equal to time taken, that is t, and AD is also equal to the time taken, t. So, I can write down OE is equal to AD is equal to t. Now, using this data, let us try to find out the first equation, that is v is equal to u plus at. We know that the slope of the velocity time graph gives us acceleration. In other words, if I am able to find the slope of a velocity time graph, then I can easily find out its acceleration. So, in order to find the acceleration for this graph, I have to find the slope of the line AC. And slope can be easily found out by calculating the change in y-axis divided by the change in x-axis, that is CD by AC. So, the slope of the velocity time graph gives acceleration. Therefore, acceleration A can be written as CD by AD. From the data, we can easily see CD is equal to v minus u and AD is equal to t. Or, now I can simply write down A is equal to v minus u by t. Now, let me take t to the left hand side and I will get AT is equal to v minus u. A simple rearrangement, that is by taking minus u to the left hand side, I will get u plus AT is equal to v. This is our first equation of motion, that is v is equal to u plus AT. From the previous derivation, we know that AT is equal to v minus u. Now, we are going to use this in the next equation. Therefore, we will add it into our data. The next equation which we are going to find out is S is equal to ut plus half at square. Here, S means the displacement of the body. Displacement of the body is given by area under the velocity time curve. If I am able to calculate this area, the area under the velocity time curve, then I can easily find out the displacement. In order to find the displacement S, I have to find out the area under the trapezium OACE. We can divide this trapezium into two parts, a rectangle and a triangle. So, if I am able to find out the area of the rectangle and area of the triangle, then I can easily find out displacement. Therefore, S is equal to area of the rectangle plus area of the triangle. Now, we know that area of the rectangle is given by length into breadth and area of the triangle is given by the formula half into base into height. The length of the rectangle is equal to DE and the breadth is equal to OE. Similarly, the base of the triangle is equal to AD and the height is equal to CD. Now from the data, we will apply all the values, that is DE is equal to U, OE is equal to T and AD is equal to T and CD is equal to V minus U. From the above data, we know that V minus U is equal to AT. Therefore, we will replace V minus U by AT. So, we will get displacement S is equal to UT plus half T into AT, that is AT square. So, we can write S is equal to UT plus half AT square. This is our desired equation. Now, before going to the next equation, we are going to use two equations which we have already obtained. That is OE is equal to AD is equal to T and AT is equal to V minus U. We know that AT is equal to V minus U and we can rearrange it and write T is equal to V minus U by A. Now we know that AD is equal to T and T is equal to V minus U by A. So, taking it together, we can write AD is equal to V minus U by A. Now let us take this AD value into our data points. Now we are going to prove the third equation, that is V square is equal to U square plus 2AS. Again we are going to use the same thing, that is area under the velocity time curve gives the displacement. That is displacement S is equal to area of the trapezium OACE. Here we are not going to split it and we know that area of the trapezium is given by half into sum of the parallel sides into the distance between them. Here, CE and OA are the parallel sides of the trapezium and AD is the distance between them. Therefore, I can write displacement S is equal to the first parallel side is CE plus the second parallel side AO and the distance between them is AD. Now from the data, we will apply all the value. CE is equal to V, AO is equal to U and AD is equal to V minus U by A. So we will get S is equal to half into V plus U and V minus U by A. Here 2 and A are in the denominator. We will take it into the left hand side. So we will get 2AS is equal to V plus U into V minus U. Now V plus U into V minus U reminds us of the formula A plus B into A minus B, which will give us A square minus B square. And using the formula, we can write it as V square minus U square. So we will get 2AS is equal to V square minus U square. Now by rearranging it, we can easily write V square is equal to U square plus 2AS. This is our final equation.